This is question 3 from the Hess Law homework. Question 3 states that the standard enthalpy of combustion of liquid cyclohexane to carbon dioxide and liquid water is negative 3,824 kilojoules per mole, as we see right here. What is the standard enthalpy of formation of cyclohexane? Okay, so we see that this is a combustion reaction. So I've written the combustion reaction for liquid cyclohexane. We also see that we are given the heat of this reaction. Okay. So we are given delta HR. Now I've written delta H combustion, delta HR is the heat of the reaction, right? But in this case the reaction is a combustion reaction, so I just write delta H of combustion is equal to negative 3,824 kilojoules per 1 mole of cyclohexane that reacts. It's asking me for the standard heat of formation of cyclohexane. So it's asking me for this right here, the heat of formation of cyclohexane for C6H12. So I can use Hess's law to find the heat of formation for cyclohexane there. I'm just going to fix that H. As follows. So Hess's law that uses heats of formation is as follows. Delta H of a reaction, which could be the combustion reaction in this case, is the sum of the N delta H of formation of the products minus the sum of the N delta H formation of the reactants. Okay, so let's start substituting values into this equation. The heat of this reaction is already given. So we are not finding the heat of this reaction, it's already provided in the question. So negative 3,824 kilojoules per mole is provided. Then we have the N delta HF of the products. So I look at my products. I have 6 carbon dioxides, so I will write, one second guys, 6, the stoichiometric coefficient, 6 times the heat of formation of carbon dioxide, so I look that up on my tables. I believe that's 394 kilojoules per mole. Negative 394 kilojoules per mole, great. And then I'm adding, because it's the sum of 6 liquid waters. 6 liquid water, so negative 286 kilojoules per mole. Great. So this here, this represents right here the sum of the N delta H's of the products right here. Now I need to subtract the N delta H's of the reactants. Okay, so N for, the stoichiometric coefficient for cyclohexane is just 1. Okay, you don't have to write 1, but I'm going to write it anyways, just so that you know it's referring to the cyclohexane. And then this is where the heat of formation comes in. I actually don't have the heat of formation of cyclohexane. So that's the unknown variable I'm going to solve for. And then the 9 for oxygen, well, oxygen is in its elemental state, so that's 0 kilojoules per mole, because as we've talked about before, that's our reference point for enthalpy. Okay, so effectively you now have an equation with one unknown that you can rearrange and solve for. All right, so I'm just going to pause the video now, and I'm going to do my calculations here, and I'll come back with the calculated values, and we can start rearranging this equation to find the N delta H of formation of cyclohexane. Okay, so what I've done here is I've effectively calculated this bracket right here, 6 times the heat of formation of carbon dioxide plus 6 times the heat of formation of water. And that value right there, or that sum of the heats of formation of the products, is negative 4,080 kilojoules per mole. And then I'm subtracting the 1 times the delta heat formation of cyclohexane, and this just becomes 0, right? Because 9 times 0 is just 0, so I don't have to worry about that. All right, I'm going to bring that negative 4080 over to the left side by adding it to both sides, right? So I have this right here, so plus 4080 and this is all in kilojoules per mole. And that's equal to a negative delta H of formation of C6H12. Okay, so I'm going to take that. 1 minute, please. Negative 3824. And I get 256 right here. Kilojoules per mole is equal to negative delta HF of C6H12. Just scrolling down now. Dividing both sides by negative 1 so that I can have a just the delta H value there. So then I have negative 256 kilojoules per mole is the heat of formation of cyclohexane. Right there. Okay. Now I know in your textbook it says that, okay, the heat of formation is negative 252 kilojoules per mole. And that's because we're using delta H's from a table that is slightly different than the table that the textbook uses. So negative 256 is acceptable because it's using the values that from the table that I gave you as opposed to the table that the textbook used. Okay, so just to recap right here, we saw it was a combustion reaction, so we wrote the combustion reaction. We saw that they actually gave you the enthalpy of combustion. Okay, so they actually give that to you right there. Okay, and then they asked you for the heat of formation of C6H12. So you used Hess's law here, or we used Hess's law here, and recognize that we already have the delta H, so we don't need to calculate this. It was given to us in the question, and the unknown that we were solving for was the heat of formation of the cyclohexane from the question. Okay, so we just did our sum of the heats of formation of the products, isolated the variable, and solved. Thanks for watching.